This video is going to cover Objective 5, and Objectives 6 and 7 I'm going to do on the handwritten tablet, so that'll be a separate video. So for Objective 5, this is acceleration, and I would like you to think of some examples of acceleration. What do you think of when you hear the word acceleration? We'll talk about that a little bit more in class, but off the top of my head I think of stepping on the gas. So that would be an example to accelerate. So it's the change in velocity over a certain period of time. So it's meters per second, because that's velocity, per second, which we write as meters per second squared. So that is the unit for acceleration. And to look at what acceleration is by looking at a graph, it's always the slope of the velocity versus time graph. So you're looking at the slope of the graph. So this is velocity versus time. If you look at the slope at the different intervals, we'll be able to figure out the acceleration. In general, on Earth, most things accelerate at a constant rate. So we won't look at changing acceleration. We'll say you're stepping on the gas and you're accelerating at the same rate through that whole time you're stepping on the gas. There are situations, though, where that does change, but we're going to look at constant acceleration here in physics class. So if you look at the different sections, you're just looking at the slope to figure out the acceleration. So you look at A to B. From this point, A to B, they went from 0 meters per second to 20 meters per second in 2 seconds. So you look at the rise over the run, and that will tell you the acceleration. So if you look at that, you got 20 divided by 2. So you got the rise over the run of this section. And you get 20 divided by 2, and that would give you 10 meters per second squared, because it's changing 20 meters in 2 seconds. So that would give you 10 meters per second squared. Looking at the next step, B through C, it's 20 meters per second in the beginning, and then 20 meters per second at the end. So you already know in your head that's 0 acceleration. And to look at the slope, there's 0 rise, and there's 2 for the run. It goes from 2 to 4. So 0 over 2 is 0 meters per second squared. C to D, you look that it goes from 20 to 40 meters per second in, it looks like, 1 second. So you got 20 for the rise, 1 for the run, so that is accelerating 20 meters per second squared. D to E, again, no acceleration. There's no rise. Looking at E to F, it goes from 40 to 20. So it's going down, so I wrote negative 20. And then it goes over 2 seconds in that period of time. So it's negative 10 meters per second squared. So you can see the sign on there. If something is heading away and it's slowing down, you'll get a negative acceleration. Then looking at this next step, you have F to G, it's 0 rise, and it's 1 for the run, so 0 meters per second squared again. And then G to H, it goes from 20 to, and so that's a change of 10. And it's over 1 second, which is 10 over 1 then, when you divide that, is 10 meters per second squared. So simply look at the slope of a velocity versus time graph line, and you'll be able to figure out the acceleration. Continuing on in Objective 5, we have a graph here. There's a velocity versus time graph, and we know velocity can be negative. Remember, velocity is negative when it's heading toward the sensor. It's negative just as a direction. So you just got to remember that in your head, that negative is just a direction. So describe the motion of the object in the graph below. So looking at section A, this part right here, you can see that it's positive, so that means it's heading away. So it's above 0, it means it's positive. So in this area, it's heading away. And you can see that this line is going upward. So that means that it's going faster and faster. So it's heading away, going faster. So speeding up, heading away. Part B, right here, you can see the velocity is constant, and it's in the positive area. So that means that the velocity stays the same. It's a constant velocity, still heading away because it's in the positive area. So you can write that down for part B there. And then take a look at C. They're looking from this point down to the 0 line. Okay, it's still positive, right? It's in the positive section of the graph. It's up here. So it's positive, so it's still heading away, but it's going towards 0, so that would indicate that it would be slowing down. And then looking at this part D, you have to be careful there, because what's it doing? It looks like this is constant, but really what happens is that it's the acceleration is constant. It keeps slowing down. So right here you can see it's slowing down, heading away, and then it stops. And then what happens? Well, it crosses into the negative in part E. So part D is where it stops, and part E crosses to the negative. That means it turned around and started heading toward the sensor, because if it's negative, that means toward the sensor. So in E right here, it's going toward the sensor, and it's going faster. It's heading away from 0. So it turns around, comes back at you, going faster and faster and faster. It's accelerating. So if you take a look at that, again, negative because it's going toward you. It's heading away from the 0 line, which is right here. It's heading away from that, so it's going faster. Then at F, it's still heading toward you, but it's going at a constant velocity because it's not changing. It's a flat horizontal line, not accelerating. And then in part G, it's still going toward you because it's still negative below the line, but it's going towards 0. So if it goes towards 0, that means it's slowing down. Either way, so this part C was going towards 0, this was going towards 0, it's still slowing down. Just negative means toward, positive means away. And then looking at A, you can see that's heading away from 0, and so is part E here. So those are both speeding up. It's just this is negative, so it's going toward, and this is positive and heading away. So I'd like you to think about what situations would you have a positive acceleration. So when would acceleration be positive? Well, you know heading away is positive for velocity, so maybe it could be something heading away from you, but what would cause the acceleration or the force on the object to be pointing away? Well, if it's already heading away from you, if you push it on its back, so give it a push in that direction, away from the sensor, it will start accelerating in that direction, which would be pointing away from the sensor, which is positive. So if you have something that is pointing away from the sensor and goes faster and faster and faster, like in this motion diagram, so away from the sensor, going faster, acceleration points to the right. You'd have to push something behind to get it to go in that direction. So your acceleration points to the right. So that would be away from the sensor, pretend this is the sensor, and that would mean a positive acceleration, a positive direction. Okay, another situation, it can get a positive acceleration even going toward the sensor. Because if you're going toward the sensor and slowing down, that means something had to push to the right to get you to slow down. Because if you're going towards the sensor, you'd have to push that way to slow it down. So again, acceleration would point to the right if it's heading towards you and decreasing in velocity. So both of those are two positive situations for acceleration. You look at which way you'd have to push on it to get it to go faster or slower in that direction, and then you can determine the acceleration. So negative acceleration is when something heads toward you, okay, so it's heading toward you and it's speeding up. That means you'd have to give it a push this way to make it speed up in that direction. And if you push it that way, that's the way the acceleration points, which is toward the detector, which is negative. Looking at the other situation, it's heading away from you, decreasing speed. So it's going this way, so in order to get it to slow down, you have to push it that way to get it to slow down. That means your acceleration would be to the left, which is towards the sensor, which is negative. So if you're heading toward and speeding up, or heading away and slowing down, those are two negative situations for acceleration. They're pointing toward the sensor.